Hello and welcome to our lesson on troubleshooting. In a perfect world, every YAML manifest we write and copy would work perfectly for the first time. But in real world, you will inevitably run into failure situation. As an administrator, your skill is measured by how quickly and calmly you can justify the root causes of your issue and fix it. This is not about magic, it's about systematic processes. In this topic, we are going to build and process. We'll start with the most common failure point, the pod, and then move up to the networking layer with services. Let's switch to the terminal, troubleshooting pods. When you deploy an application, whether it's a single pod or deployment, your very first step is to check the high-level status. So we are using kubectl get pods. We have done it multiple times in these courses. Your first command should always be kubectl get pods. You are immediately looking for three key columns: ready, status, and restart. So let me use get pods. And as you can see, we have a container in not ready state, in container creating status. So let me just create another container. I'm using kubectl run, and I'm using echo server, and I'm using image of echo server. So if I'm getting the pod status again, you can see that echo server is running. This is the happy path. Ready is 1/1, meaning 1 out of 1 of container in the pod is running and passing readiness prop. Status is running, restart is 0. The pod look like healthy. But what if you see unhealthy get pods output from the get pods? But let's create another example. Right now I want to create an image pod which has incorrect image tag. It's wrong tag address. So as you can see in the image field, I'm using wrong tag as a tag for this Nginx pod. So if I create this pod, let's say kubectl apply and creating this pod. So this immediate obvious problem, the ready column is 0 out of 1. And status gives us huge clue, error image pool. You will quickly learn to recognize this common error status. Error image pool or image pool backup, this is one of the most common errors. Kubernetes cannot pull container image. You should immediately check, did you spell the image name and tags correctly? Does that image and tag actually exist in registry? Is the registry private and you forgot that add to image pool secret into your cluster? Another example is crash loop backup. This means that the container is starting, but it's crashing or existing immediately. Kubernetes tried to be helpful by restarting it, but it just keep crashing in a loop. So I already have an example of the crash loop backup. I'm listing my files, and I have this deployment for crash loop backup. You can see that the command is bin-sh-c, which is running nothing. It's just trying to run a command line which does not exist. So if I'm running this pod, basically it's crashing each time that it's run. Okay, so let's just create this deployment. Okay, apply-f deploy YAML and check the deployments. But as you can see, as it's starting, it's facing error. And if this error repeat again and again and again, it means that each time the container is running, it's facing error and it's exiting quickly. So the container runtime tries to restart the container again, but each time this container is running, it's failing error. The next step is digging deeper. But what if the status is vague? Well, for example, your pod might stuck in container creating or pending for a minute. Let me just show you an example of container creating. So as you can see, this Nginx with secret is in container creating state, which means that it's not saying anything right now on status. So the next step is to digging deeper. The useful command for understanding more is kubectl describe using pod as a resource and then a resource name. When you run describe, you should scroll directly to the event section of the bottom. This is the logbook of what Kubernetes has been trying to do. And there is one answer, plain as the day. Warning event for failed month tell us that my missing secret is not found. The pod stuck is container creating because it cannot start until it mounts the volume. And it can't mount the volume because the secret was referenced in the YAML file doesn't exist in the namespace. The event section will solve vast majority of our scheduling and startup. Let's take a different scenario. Your pod has a status of crash loop backup, like Nginx crash in our case in the deployment. So the describe command will just tell us the container is failing, but it won't tell you why. For that, you need to ask the container itself. We need to see the log output. So let me just describe the pod in our deployment. The describe command will tell you that container is failing, but it won't tell you why. For that, you need to ask the container itself. We need to see its log output. So first, let me describe the failing container. As you can see, okay, describe pod because the resources is important. And then you can see that the backup restarting failed container nginx doesn't show us the actual reason why it's restarting. So the next step is to getting the log from this container. And as you can see, it's printing out that the bin sh -c require an argument. And there is our root cause. The command we specified in our pod YAML manifest was unknown, which is a real command. The container tried to run it, failed and exited. Kubernetes restarted it and failed it again, over and over, resulting in crash loop back. Two crucial flags for this command. kubectl log-f pod name. -f flag will follow the logs, streaming them into your terminal in real time. This is essential for debugging the live issues. And another flag is -- previous. Remember, in a crash loop backup, the container is constantly restarting. Running kubectl logs will give you the logs for the current crashing container. If you want to see the logs from the last time it's tried to start using the previous flag. So if I'm using the -- previous flag on the nginx crash loop container, you can see that it uses it's printing me the -c require an argument. It means that the previous time the issue was also having the not having argument for this. The last step is interactive shell. This is your final and most powerful use. What if a pod is running, the ready status is 101, but the application is just not working? Your ingress get 502 or the application isn't processing the data. Let's look at this pod. So I'm creating another pod. This time the pod is failing loop pod. So I already have the YAML manifest here and the name is failing loop pod. As you can see, the logic here is that if the date this root temporary directory exists, then successfully wrote that yeah the date is appending into the file. But if this addresses doesn't exist, then say fail to write into the designated location and sleep for 5 seconds. So this is very basic logic. Basically right now, if we check the container, if we create the container, this address root/temp doesn't exist. So right now I'm applying the manifest. You can see that the container failing loop is running and it's 101. But let's check the log and see what is in the log status. Okay, logs-f. As you can see, it's failed to write into the root temp current date because the directory is not exist. So our next step is to executing into the pod. So we see the error. The application is running, but internal logic is failing because a directory is expected to find it doesn't exist. Fix this, or at least confirm the problem, we can use kubectl exec to get interactive shell inside of our running container. Here is the pod name, and then I'm using bash as my interactive shell. So if the bash does not exist in the container, I'm using shell instead. Sometimes our containers are so tiny that doesn't supporting bash. So in some cases like BusyBox, Nginx, Alpine, they are all using shell instead of bash. So right now we are inside of the container file system. Let's see if that directory exists. So the directory was root/tmp. So I'm going to use ls-la. And as you can see that there's no such file or directory. This is the first line. So I'm gonna use mkdir-p and then /tmp. This will create a temporary directory into my home, which is /root. To be more deterministic, we can use /root/tmp. Okay, right now we have this root/tmp directory. So let's check as you can see, the current date text exists here, but let's check the logs again. And as you can see right now, it successfully wrote into the root tmp current date. The application is now working. We have found the root cause. The permanent fix, of course, isn't the exec and create a directory, but to fix the container image to create the directory on a startup. So the next step is troubleshooting the services. Okay, you have gone through all of these steps. Your pod is running, the logs are clean, and you can even exec into and see the process is running. But you still can't connect to it through your service. The problem isn't the pod, it's the service. Here is 4-step checklist. Do the label match? A service finds its pod using label selector. If a service finds its pod using a label selector. If a selector doesn't match the pod label, the service will have no idea where to send the traffic. First, describe your service and find the selector. So let me get the services. As you can see here, right now we have two services here. And let me describe the echo server service. Okay, describe echo server. The service is looking for pod with the label app equal echo server. Now let's check the actual label on the pod. So I'm using this command, kubectl get pods and -- show labels. This is showing us the labels on our pods. As you can see on the echo server right now, the label is run equal echo server, not app equal echo server. And there's the problem. Our pod has label run equal echo server, but the service is looking for app equal echo server. They don't match. Are there any endpoint? The most direct way to confirm that label mismatch is check to the service endpoints. The endpoint objects is the list of actual IP that service will send traffic to. So I'm gonna use kubectl get endpoint, and then I'm using the services right now, echo server service. If endpoints is none, it's 100% confirmation that your label selector is wrong, or that no pod with those labels are in ready state. If the type is cluster IP, remember that IP address is only reachable from inside of the cluster. If you are trying to hit the IP address from your laptop, it will never work. You can verify internal connectivity by spinning up a temporary test pod. So right now we have to fix two issues. First, fixing the label selector because it's run equal echo server, and the next is to using a busybox image to connect to the echo server. So first, let's try to connect to the service on port 8080, but without the actual the service is not working properly at the moment. So as you can see, it cannot get remote host because connection refused. Now we should fix the service label selector. Let's use kedit, svc, and echo server. So right now, this is the YAML manifest of our service. So we can use the edit command to edit the current YAML file. So here the selector is app equal to echo server. I'm changing it to run equal echo. So right now, let's get the endpoint for this service. As you can see, it's 172.188.148.8080. This means that right now the service is sending traffic to its designated pod. So right now, after changing the service label selector and checking that the endpoint is correct, like let's see that service and get the endpoints, which is pointing to our pod. We can use curl command in our cluster and see that this is responding. So this service now responding to our request. Are the port mapped correctly? Finally, check the port mapping. A service has a port and a target port. The target port for the service must match the container port in the pod. So the first step is to checking the service ports. Let's check the SVC echo server, and you can see that the port is 8080 and it's pointing to the target port 8080. But let's check the pod, because we should also see the container port in the pod, but it's not mandatory. Right now, the pod is listening to 8080, but it doesn't have any tag or any port that's showing us this pod is listening to that port. Basically, the recommendation is to use the container port to make sure that you are aware of what kind of port that's running on that container. But it's just not mandatory. You can just leave the pod without any container port because it's already listening to 8080 and it's not like doing anything special. It's basically good for like the service to have some name to attach. Thank you for watching. In next topic, we are going to troubleshoot the infrastructure.